Hi everyone, today let us know about harmonic oscillators. These harmonic oscillators, this concept is used in quantum field theories. What is meant by harmonic oscillators? These are nothing but oscillators which follows the principle of SHM, that is simple harmonic motion, and these harmonic oscillators we can see this in oscillation chapter, which is in intermediate. From basis of it, we use our mathematical concepts like Hamiltonian, Lagrangian, and so others. This concept is used in quantum theories. So we already know that Poisson bracket. This is a composite of Poisson bracket and n minus 1. This is the position coordinate and this is of momentum coordinate power n. And if here the power is 1, then we get gamma is equals to I. For harmonic oscillators, if we write the equation of harmonic oscillator in the form of Hamiltonian, that is its kinetic energy plus its potential energy. And in previous videos like Hilbert space and about Heisenberg picture, Schrödinger equation, Schrödinger picture, in that we have already solved this. Psi of x plus half m omega square x square psi of x is equals to E of x. Let me say you an general equation in Schrödinger related to Schrödinger equation, that is Hamiltonian of x into this is wave function and this is energy eigenvalue and this is also the wave function. These wave function and eigenvalue depends on this Hamiltonian, and later let us continue our derivation that this is equals to root m omega x. I have made this for to make our derivation much easier. So as this is a double time derivative, it can be denoted as, and by using these two, let us write the above equation in the form minus psi of second derivative of x m square omega square x square psi of x is equals to 2me psi of x. Let us take this on the other side, minus m square omega square x square psi of x plus 2me psi of x. Let's take psi of x common, plus psi of x of 2me minus m square omega square x square. And this above equation can be written as epsilon minus square is equals to 0. This is second degree Hermitian polynomial. This can be solved using multivariable calculus and differential vector calculus. For this above equation, let us use Rodriguez formulas for Hermitian polynomial. For Hermitian polynomial, the Rodriguez formula is as follows. That is, hn of x is equals to minus 1 for n e power x square dn by dx power n e power minus x square. In form of polynomials, it can be written as 2x minus t by power n into 1. And if we use this equation, we get hn of psi is equals to minus 1 power n e power psi by x to dou n by e power minus square by 2 by dou n. We get this equation. And let me say you other two Rodriguez formulas for Legendre's polynomial and Laguerre polynomial. That is, for Legendre's polynomial, Pn of x is equals to 1 by 2 power n into n factorial dn by dx power n of x square minus 1 of whole power n. And for Laguerre polynomial, it is written as ln of x is equals to dn by x power n of e power minus x dou x minus 1 of whole power x into x power n. If you are interested in deriving these equations, you can get their solutions from Google. And now let me say you another important point, that is, Rodriguez formulas are formally called as Ivory Jacobi formula. By taking the relation of Hermitian polynomial and the wave function, we get is equals to root m omega by 2 power n into n factorial root pi hn of I power minus square by 2. Let me show you the relation between wave function and the Hermitian polynomial. Minus 1 by 2 power x square by 2 gen of x. This is the relation between wave function and Hermitian polynomial. And let us see this derivation in more simplified form. And we introduce two operators known as annihilation operator and creation operator. And we have, let us see one dimensional, that is 1D time independent Schrödinger equation, that is as follows: by 2m d square by dx square plus psi x. This is same as the previous equation. And let us non-dimensionalize this equation. Non-dimensionalizing is a process of making the equations dimensionless. For non-dimensionalizing, let us take x is equals to h m omega into q. Using this term, we can non-dimensionalize this above equation. By substituting this in the above equation, we get h omega by 2 into minus d square by dq square plus q square psi of q is equals to q. From this equation, let us substitute h omega is equals to h. This is angular frequency or angular velocity, and this is frequency. That is, let us take h omega is equals to h by 2 pi to omega, where omega is equals to 2 pi, that is omega by 2 pi is equals to, then we can write it as in this form. Then as we have substituted the x is equals to h omega by q of 2m in previous equation, then we have got q square minus d square of dq. This is in the form of a square minus b square. This can be written in the form of q minus d by dq of d by dq plus q plus dq by dq minus q of d by dq. To get this value, let us consider an function f of q and multiply this function to this, and we get d by dq into q minus q of d by dq of f of q is equals to d by dq of q f of minus q by q. This is equals to f of q, that is d by dq into q minus, from this we can consider that as we have substituted the f of q value multiplied f of q value in this, and our result is f of q. That means substituting this equals to 1, we get our final result as f of q. So we consider that this equation is equals to 1, and from the Heisenberg uncertainty and Schrodinger pictures, we have already solved that x comma, and at the starting of this video I have said you that q comma p is equals to I and if you multiply and divided with I and I, we get minus I of q comma p is equals to 1. And in canonical quantization, we have already derived the position space representation, that is p is equals to, that is momentum is equals to minus I d by dp. Let us substitute in let us use this in our below equation. We can write our first one-dimensional Schrodinger equation as follows: by root 2 if you solve this equation, you get one-dimensional Schrodinger equation that we have obtained after non-dimensionalizing it. So This equation can be written as h omega by 2 of 1 by 2 q minus d by dq of q plus d by dq plus 1 by 2. Psi is equals to E by taking 1 by 2 common, we get h omega by 2 of q minus d by dq q plus d by dq plus 1. This is similar to that of q square minus dq square, d square by dq square. This can be written as h omega by 2 q square by d square dq square of psi is equals to E psi. Now, from the previous equation, that is h omega of 1 by root 2 of q minus d by dq into 1 by root 2 of q plus d by dq plus 1 by 2 of psi is equals to E psi. I have already said we introduce the creator operator and annihilation operator in this Hamiltonian oscillators. Let us say this as annihilation operator, creation operator, and this as annihilation operator. Creation operator is also known as rising operator. It is denoted by a part, and it is equals to d by dq, and by resubstituting the q values, that is from x is equals to h by m omega q, by substituting the q value, we get an creation operator as root of, write our creation operator in the form m omega by 2 x cap minus I of by 2m omega p cap. This is our creation operator. In the same way, we denote this as annihilation operator, or this is also called as lowering operator, and this is denoted by A, that is equals to don't confuse from creation and annihilation operator. In creation operator, as he has given that rising operator, but we have a sign of minus and it is lowering the value. Take the opposite of it so that you can easily remember that. Creation operator can be written as this, and annihilation operator is written in this form, and this is written in the form omega by 2 x cap plus I of 1 by 2 m omega p cap. We get this equation by substituting the q values, that is x is equals to here, where q is equals to root m omega by h into x. And now let us know about some of the properties of creation and annihilation operator, that is before that we have already seen the equation 1 by root 2 of q is q plus d by dq of 1 by root 2 plus 1 by 2 of psi is equals to E psi. This is represented using the annihilation and creation operator, that is psi into A plus 1 by 2. Psi of, as it is in the form of function of q, we represented function of q, and as before I have said, this position space representation, that is momentum is equals to minus I d by dq, and this can also be written as ip is equals to dp by simply multiplying and dividing with I. And we have also seen that q of q comma p, this bracket is different from the normal brackets that we use. This is called as a Poisson or complex. This is the complex of Poisson bracket, so that we got I. If we just use the Poisson bracket, then we get q comma p is equals to 1. This is for this is the value of Poisson bracket, Poisson and this is the Poisson bracket, and this is the complex of Poisson bracket. And now let us see some of the properties, like in using the complex Poisson bracket, annihilation operator and creation operator, we get 1. Let us see about it. As annihilation operator can be written as q plus ip. As we know that annihilation operator q plus d by dp. D by dp can be represented as ip, we have already seen here, and comma q minus ip is equals to half of these can be using bilinear forms. This can be written as q minus ip plus 4 q plus ip, and using the same bilinear forms properties, we get, taking minus I common, q of p plus q of p. We have already seen that complex Poisson bracket of q and p, we get I. So minus I by 2 of I plus I, get minus I by 2 of 2I at 1. So a comma is equals to 1. Similarly, we get a comma a is equals to 0, and creation operators get 0. These are some of the properties that you have to remember, and these multiplication of annihilation and creation operator gives you number operator, which is denoted by number operator n is equals to a into, that is annihilation operator into creation operator. And we can also relate this to the Hamiltonian, that our Hamiltonian equation can be written in the form, at the beginning of this we have already seen that h cap is equals to c cap or square plus 1 by 2 m omega square, and by using this we can write our Hamiltonian in the form of annihilation and creation operator, that is h cap is equals to h omega by 2 h omega a by 2. These are conjugate complexes. These are also conjugate complexes to each other, and using the conjugate Poisson bracket, we get omega a comma a equals to, these can be written as h omega of comma plus a comma a of a star. As we have already seen that our complex Poisson bracket a comma a star is equals to 1, and a plus or a power t creation operator comma annihilation operator is equals to -1. So we get h omega of 2 minus 1 plus, and this is equals to 0 of a. Then we get minus h omega, that is h cap of annihilation operator, and h cap of creation operator in complex Poisson bracket use h omega a star. From this we have completed our concept of harmonic oscillators in quantum theories, and this would be much easy if you practice, and it is a useful method for solving many problems in quantum theory. This is a basic one, and you can see much other properties of annihilation and creation operator. This is much related to mathematics and less to physics, and these are used in quantum field theories. So now we have completed our Hamiltonian oscillator concept.